So what we have here on this TI Nspire software is a graph of y equals x cubed minus 3x. And my goal is to create a graph of the inverse of this given function. So to do that, we need to remember what an inverse is. It is the set of all points whose x and y coordinates are reversed. So in effect, what used to be input is now output, and what used to be output is now input. So I need to first put a point on my given function. It really doesn't matter where I put that point. And then I'm going to go to the construction menu, and I'm going to do a measurement transfer. For the inverse, the value of the x-coordinate appears on the y-axis, and the value of the y-coordinate appears on the x-axis. Returning to the construction menu, put a perpendicular to the y-axis through its given point, a perpendicular to the x-axis through its given point. And when I put a point at the intersection of these two perpendicular lines, the result must be a point on the inverse because its x and y coordinates are reversed from the given point. Go to the Actions menu just for a moment to clean this up a little bit. It'll help us see what's going on. I'm going to hide the points on the axes and the perpendicular lines because they're no longer required. If I wanted a quick dirty look at all the places where that inverse could be, I could certainly grab the point and move it around. If I decided instead to put a geometry trace on this, it can leave some footprints there on the graph. So as I move my point around on the original function, the inverse is now tracing out its possible locations. The problem with the geometry trace is that it only has a finite number of locations. It's kind of cool that you can actually see this thing in development, but it's limited in the number of points that it can show you. So I'm going to erase that geometry trace for a moment here. Return to the construction menu one last time and do a locus. Remember, a locus is a set of all points defined by a given condition. So I really want to see for this inverse what are all places where the inverse point could be when the original point travels around its function. The resulting locus curve is the set of all possible locations for this inverse. So this really is the inverse curve. Algebraically, this would be represented not by y equals x cubed minus 3x as for the original function, but now x equals y cubed minus 3y. We have the graph of the inverse. And the beauty of this approach is that it applies to any kind of given function that you have. You can create this anywhere with any kind of curve, whether the inverse, as we see right here, is not a function or is a function, completely irrelevant. A very powerful visual way of understanding what an inverse is.